Finally, a little lighter example than the last couple.
I got a bad feeling about this.
Oh, but you shouldn't feel bad because it's not too bad at all, really. We're just going to find xp for this system. dx dt equals 3x plus 2y plus 7t, and dy dt is x minus 4y minus 3. So if you look at the vector f, 7t plus 0 and 0t minus 3, it's logical to assume we'd have to have a vector xp of this form: a times t plus b and c times t plus d. So when we do that, we've got the equations. If this is our x, right, so the derivative of that, of course, is just a. So a equals 3 times at plus b plus 2 times ct plus d plus 7t. Well, that is a complicated bugger, right? And similarly, dy dt, well, the derivative of that's just c, so c equals x, which is right here, minus 4y, which is right here, minus this 3. This looks pretty ugly, but keep in mind, the terms without t and the terms with t have to be equal. So a equals 3b plus 2d, and the terms with t have to be the same too. So 3a plus 2c plus 7 has to be 0 because there's no t on the left side of that equation. And so that gave us two equations with 1, 2, 3, 4 unknowns. Look, here's two more. The t parts have to be the same, so well, let's say the constants have to be the same, so c equals b minus 4d minus 3. And the parts with t have to be the same, so I guess a minus 4c has to be 0. Yeah, because the t parts have to be the same. A minus 4c has got to be 0. So that gives us 4 equations with 4 unknowns. But this one's pretty easy. I mean, a equals 4c, and so if we put that back in, let's say here for a, then we got 3 times 4c plus 2c plus 7 equals 0, so therefore 14c plus 7 equals 0, so c equals negative a half. So we got c is negative a half, and if we know c, then we got a, so a is negative 2. So now what? Well, if a is negative 2, then we got negative 2 equals 3b plus 2d. And if a is negative 2, we could put that, actually, that we don't need a, we need c. c is negative a half, so negative a half equals b minus 4d minus 3. So now we have this system of equations. 3b plus 2d equals negative 2, and I represent that with the top row of this matrix, and b minus 4d equals positive 5 halves if I add the 3 to both sides of this equation. So let's do this row operation. 1/3 of row 1, we get a 1, 2/3, and negative 2/3. And then negative row 1 plus row 2 gives us the 0 here we were hoping for. So we got 1, 2/3, negative 2/3. Negative this, add to this, 0. Negative this, add to this. Oh, I might have to think about that a while. Well, that's 12/3 and subtract 2 more, so negative 14/3. And negative this, add to this would be 2/3 added to 5 halves. So we'd have to go to 6. That's 15/6 plus 4/6, so 19/6. Okay. Then we want a 1 here, so let's do negative 3/14 times row 2, and that'll turn us a 1 here. Oh, now it's ugly. Negative 3/14 times 19/6, trust me, it comes out to be negative 19/28. And finally, we're going to do negative 2/3 times row 2, add to row 1 to make a 0 here. And so we get our 0 here without a hassle. Negative 2/3 times this, add to this, still 1. Negative 2/3 times this, add to this, turns out to be 0. Here's the ugly part. Negative 2/3 times this, added to negative 2/3. Well, so it's going to be I confess, I don't want to do that arithmetic, so negative 19/28 times negative 2/3 minus 2/3 is negative 3/14, and that's what I have here. Okay, that's enough. Here's a calculator. Anyway, we've got our B, we've got our D, we've got our A. Where was it? Here, and we've got our C, and so we've got our XP, A times T minus B, and C times T plus D, which is negative 19/28. So that's it for this lesson.